Now here is section 7.3, exercise 34. And in this exercise, we need to use technology. They give us that y equals the square root of 1 minus x cubed, and they bound things by y equals 0 and x equals 0. So they tell us to use technology to graph this and then determine the volume of revolution. Well, so we will do that, but we have x equals 0 here is the y-axis. Y equals 0 is the x-axis. And then this function 1 minus x cubed square root of that, it ends up doing something like this. So we're in here, and we want to revolve around the y-axis, it says. And so I could either make disks, in which case if I did that, I do know, this x equals 0, I get 1 for y, and if y equals 0, on the other hand, I also get 1 for x. So if I did a disk like that, I would need to find the inverse of the function I have here, which it does have one. So, I could have y squared equals 1 minus x cubed, and so then x cubed equals 1 minus y squared, and then x equals the cube root of 1 minus y squared, and I could set up that integral. I would need y to go from 0 to 1, and I would need, since these are disks, I would need pi r squared, so there's pi, and I get 1 minus y squared to the 2/3, and then dy. So great, I can do that, and I could evaluate it that way. Now, actually, I didn't want to do this inverse thing, so when I did this on Desmos, I said, well, let's use shells here to go around the y-axis. And so if I use shells, again, we have our 2 pi r, so 2 pi, now x is going from 0 to 1, and the radius, right, is just a given x value here. And so 2 pi r is that, and then times the height is our f of x, which is the square root of 1 minus x cubed, and then that's dx. And so either one of those integrals should do it for me. So let's take a look at Desmos. So I did, I just graphed the functions, and we're in the middle there. Now you can get a little fancier, and since I wanted things that were less than f of x, I wanted to be in this area below the red curve. So I had y is less than or equal to f of x. But I could also stack on top of that other things. I needed to be to the right of, well, I guess I did y equals 0 next. So I needed to be above y equals 0, or the x-axis. I needed to be to the right of x greater than or equal to 0. And so if I put that in Desmos here with the curly braces like that, I can actually get a nice picture of the region I want. So then I already did the integral, so 2 pi r, or x in this case, because that's what we had, and then times the f of x up here that I defined. and we get 2.322. Now, I have not done the disk method. According to the disk method, right, we need pi times that integral. And once again, the integral went from 0 to 1. And then we had our r squared, which was 1 minus y squared. But I'm gonna use x. So 1 minus x squared in parentheses. And then that was, I need that to the 2/3 power, I think it was. So 2 divided by 3. And then dx, I believe. And notice we do get the same answers there. So 2.322. So either of those methods would work. We had the shell method first, which is what I preferred because I didn't have to do the inverse thing. But then if I did the disk method and did the inverse, I could also get it that way. But that's the only way we were going to be able to get our integrals, because otherwise we wouldn't know how to do it. All right, so there's number 34.